afternoon. My name is Nate Delson, and as an engineer, I draw in 3D and I think in 3D. And it turns out that there's a name for that. It's called spatial visualization. And here's an example where you have to mentally rotate an image in your mind in order to solve the problem. Now, it turns out that a student's ability in spatial visualization is correlated with their grades in math, science, and engineering. And it's useful in many areas. So spatial visualization turns out to be important. But it's not taught. It's not taught in K through 12, and it's not taught in most universities. And one of the leaders in the field, Professor Cheryl Sorby, did a study, and she showed that women and other underrepresented minorities in the math and sciences score lower on spatial visualization tests. Or maybe they played less with Lego when they were growing up. And what Professor Sorby did was she developed just a one-unit class to teach spatial visualization, and she tracked those students and showed that those students' GPAs increased in the math and sciences. So just in the last few years, NSF has started to fund classes at a number of universities in spatial visualization, but they're using the traditional method of paper and pencil and a teacher in front of the classroom. So what we wanted to do, and what we were able to do with the CRSO funding, is that we wanted to explore the use of tablets or touch interface. Everybody's familiar with touch on a cell phone or a tablet or now Windows 8, but really we're just beginning to explore what you can do with touch interface in education. And we believe that spatial visualization is a great application for enhancing the educational experience through touch. So our goal is truly to provide spatial visualization training to millions. We're starting at the university, but ultimately we'd like to go to K through 12 and vocational schools. We're collaborating with Professor Sorby. We've chose to work with an iPad to start with. We've already implemented a touch interface for interacting with 3D objects. We've also spent a lot of time focusing on a sketching application. And it turns out that the physical act of sketching is been demonstrated to be important to the learning process. And right now, we're working on an automatic grading algorithm. So when the person is sketching, they can get immediate feedback. The teacher can see what areas students need more help in. And eventually, you could have some self-guided learning. So let me show you what we've done with the touch interface. So here the student is moving the object in 3D to solve one of those rotation problems. And you can see how beautifully it just moves so automatically and interacting with virtual objects. Here is our sketching app, and you notice that we have a grid background and a starting location, which is specified with that orange dot. And that's what's going to help us with our grading algorithm. And here is a more complex sketch, which you're looking at. There's a coded top view, and the person is, we took screenshots of somebody drawing this sketch. We're at UCSD trials right now. We have a group using an iPad and a group using just paper and pencil. We're going to see how well they do. Hopefully in the summer, we might even be able to have a self-guided learning group. And I'd like to introduce you to the team of people who've done this from structural engineering, mechanical engineering, and they've put in their time pulled it from thin air. If anybody's interested, I have my iPad with me, and they can take a look at the app.